The internet is a vast network. It connects computers all over the world. Think of it like a giant web. Each strand of the web is a connection. These connections allow computers to talk to each other. The internet uses a special language. This language is called TCP/IP. It helps computers share information. This language ensures that the information is sent correctly. The internet is always growing. More and more computers are connecting every day. This makes the web even bigger and more complex. It allows us to connect with people and information from all corners of the globe. We use words to identify websites. These words are easy for us to remember and use in our daily lives. These words are called domain names. Domain names are unique addresses that help us find specific websites on the internet. For example, google.com is a domain name. It's a simple and memorable way to access Google's vast array of services and information. However, computers don't understand words. They understand numbers. These numbers are known as IP addresses. To connect to a website, your computer needs its IP address. An IP address is a unique string of numbers that identifies each computer using the Internet Protocol to communicate over a network. An IP address is like a phone number for a computer. Just as you need a phone number to call someone, your computer needs an IP address to connect to a website. DNS is like a phone book for the Internet. It helps translate the domain names we use into the IP addresses that computers understand. It translates domain names into IP addresses. This process is essential for navigating the internet efficiently. When you type a domain name, your computer asks a DNS server for the IP address. This request is sent out to find the correct numerical address. The DNS server looks up the domain name and sends back the IP address. This response allows your computer to know exactly where to go. Now, your computer knows where to find the website. This entire process happens in just a few seconds, making our browsing experience seamless and efficient. When you click a link, a fascinating journey begins. Your computer sends a request to the internet. This request is encapsulated in a small packet of information. Think of it like a digital letter, neatly packed and ready to be sent. The packet contains your computer's IP address, which acts like a return address on a letter. It also includes the IP address of the website you want to reach, similar to the recipient's address on a letter. The packet then embarks on its journey, traveling through many different networks. It's much like a letter passing through various post offices along the way. These networks are interconnected by devices known as routers. Routers function like traffic controllers, directing the flow of data. They ensure the packet is guided to the correct destination. The packet might traverse different paths to reach its goal. This depends on the current traffic conditions on the internet. Sometimes a particular path might be blocked or congested. In such cases, routers dynamically find alternative routes to ensure the packet successfully reaches its intended destination. Section 4. Servers. The internet's hard workers. Websites are stored on special computers. These computers are called servers. Servers are like libraries of information. They store websites, images, videos, and more. When the request packet reaches the server reads it. It understands that your computer is asking for information. The server then prepares a response packet. The response packet contains the website's data. It could be text, images, or videos. The server sends this packet back to your computer. The response packet follows a similar path back to your computer. Section 5. The speed of light and other hurdles. The internet is fast, but it's not instant. Despite the incredible speeds we experience today, there are still limitations that we must consider. It takes time for data to travel. This delay, although often imperceptible, is a crucial factor in the performance of our digital communications. The speed of light is the fastest speed possible. In a vacuum, light travels at approximately 299,792 kilometers per second. However, even light takes time to travel around the world. For instance, light takes about 134 milliseconds to travel from New York to Sydney. The distance data travels affects speed. The farther the data has to go, the more latency we experience. The farther the data has to go, the longer it takes. This is why international communications can sometimes feel slower. The type of connection also matters. Fiber optic cables, for example, offer much faster speeds compared to traditional copper wires. Some connections are faster than others. This can be due to the technology used, the infrastructure in place, and even the quality of the service provider. Many organizations work to keep the internet running. They ensure that the infrastructure is maintained and upgraded regularly. They make sure the connections are working. Regular maintenance and troubleshooting are essential to prevent disruptions. They also develop new technologies. Innovations in networking equipment and protocols help to push the boundaries of speed and reliability. This ensures the internet is fast and reliable for everyone. As technology continues to evolve, we can expect even faster and more dependable internet connections in the future.
If you like the video, please like, subscribe and share.